In our first section, we'll be talking about an introduction to probability. Just to give you an idea for where we're headed, we'll first discuss what is probability. That'll be this video. Then we'll hit some key concepts. We'll talk about something called counting probability that generates a lot of the important examples you'll need to understand. And then we'll talk about some laws of probability that underlie how the math works. So, what is probability? Well, every day we face a lot of uncertainty. For example, we don't know whether it will rain. We don't know how long the morning commute will be. We don't know how well our stock will do over the next month in the market. Probability is an important way to put numbers to these uncertainties. And these numbers are important because they'll influence our decisions. For example, with probabilities of certain events happening, we can then perform calculations which lead to decisions. Should I take an umbrella to work or not? Should I invest in a certain stock or not? So the first thing we'll do is just get familiar with the basic notations that we'll be using, and we'll talk a little bit about what it really means when we say that the probability of an event is, say, 70%. So let me write a couple of things here. Let's say that you knew the probability it was going to rain today was 70%. So we'll use this PR notation to denote the probability of an event. In this case, we'll say the probability that it rains is, and then instead of 70%, I'm going to write 0.7. Generally, we'll use numbers between 0 and 1 rather than percentages to denote probabilities, but you'll hear me refer to them interchangeably. As another example, we could write that the probability of a stock drop is, say, 0.06 or 6%. So what do these numbers really mean? When we talk about probabilities, the most useful interpretation is often for long-run frequencies. So, for example, if I know that the probability today that it will rain is 70%, this means that if I were to look at a lot of days that were very similar to today, say hundreds or thousands of these days, about 70 out of every 100 of these days would have rain. Similarly, if the probability of a stock dropping is 6%, you can think of this as meaning if I could somehow replicate the exact market conditions over and over again, day after day, and run a ton of simulations, say 10,000, every 6 out of 100 of these simulations would result in a stock dropping. So when we're thinking about probabilities, it's useful to think about these as long-run frequencies.